Hi, good morning. Today we will see LMTD analysis problem with solution. The problem is on counterflow heat exchanger. The problem is on counterflow heat exchanger. So you can subscribe my channel for more videos on heat transfer. Uh, Let us go to the problem. So in a counterflow double pipe heat exchanger, so the heat exchanger is double pipe heat exchanger counterflow. Water is heated from 25 to 65 degrees centigrade. So here water is heating from 25-60 degrees by an oil with a specific heat of 1.45 kilojoules per kg Kelvin, and mass flow rate is given 0.9 kg per second. The oil is cooled from 230 to 160. Oil is cooled from 230 to 160. Overall heat transfer coefficient is given as 420. We need to find heat transfer rate Q. Next thing is we need to find mass flow rate of water MC, and surface area A we need to calculate. So now we need to concentrate on the given data. So here this is given 25 degrees is now, that is called as TCI, cold water inlet temperature. This will be TC naught. This TC naught, cold water outlet temperature. Next one is this is specific heat of oil is given, that is CH. Oil is hot fluid because its temperature is decreasing. And next thing is mass flow rate is also given MH. This is given as MH. Next one is oil is cooled from 230. This is THI. This is THI, that is 230, and this is called as TH naught. TH naught is equal to 160, and 420 is overall heat transfer coefficient, that is U. U is overall heat transfer coefficient. So this is the given data. If you analyze the given data, so you can go to this is the given data. For hot fluids now they have taken capital letters T1 and T2. So T1 is nothing but THI only. T2 is nothing but TH naught only. Similarly, T1 is nothing but cold fluid TCI. T2 is nothing but the cold fluid outlet temperature. So cold fluid now this is called as TCI. This is called as TC naught, and this is called as specific heat is given, that is CH value, and MH is given. MH is 0.9, and this is called as THI. This is called as TH naught, and U is given as 420. So since it is a counterflow heat exchanger, the temperature profile will be the temperature. So hot fluid will be flowing like this. This is flowing like this. This is flowing like this. This is THI and TH naught, and cold fluid will be traveling in the opposite direction. That is TCI, and this is TC naught. So temperature difference at section 1. No, this is section 1. So we can write it as delta T1 is equal to. So this is THI means T1 minus TC naught means T2, small T2. Similarly here TH naught means capital T2, TCI means small T1. Therefore delta T2 is equal to, we can write it as T2 minus T1, T2 minus T1. So now let us, our aim is to find heat transfer rate Q. Next one is MC, mass flow rate of water, and surface heat exchanger. So Q is equal to MC delta T. Q is equal to MCP delta T is there, no? So here mass is mass flow rate of hot fluid, CP is specific heat, temperature difference, not T1 and T2 is there. That is nothing but THI minus TH naught, no? So if you substitute the value 0.9, 1.45 into 10 power 3, and this value is 230 and 160, we will get the Q value is equal to 91.35 into 10 power 3 watts. So like this we are finding the this is called as the rate of heat transfer. This is called as the rate of heat transfer. So this is about the rate of heat transfer. Next case is we are finding the surface area. So in order to find the surface area, the formula for LMTD method will be this is our standard formula for LMTD method. The formula is Q is equal to UA or AU, UA LMTD, LMTD of counter fluid exchanger. So LMTD is formula you can remember. So that is nothing but delta T1 minus delta T2 by ln of delta T1 by delta T2. That is called as LMTD. This one. So that is equal to delta T1. Now in the previous case we have written this thing. This is delta T1 and this is delta T2. So here LMTD LMTD is equal to T1 minus T2, that is section 1 temperature difference, minus T2 minus T1, that is temperature difference at section 2, divided by ln of T1 minus T2 by T2 minus T1. So like this we are finding the LMTD. Substitute all the values. 230 minus 65 minus 160 minus 25 divided by ln of 230 minus 65, 160 minus 25. So if you calculate this value, the value will be coming around 149.49. So you take the standard equation, you substitute all the values in the standard equation, that is Q is equal to AU LMTD. So you will get Q is already calculated 91.35 10 power 3. U is given in the problem 420. Area we need to find, and this is LMTD. Just now we have calculated 149.49. So from this A is equal to Q by U into LMTD. So if you calculate, means the value will be coming at a surface area will be 1.455 meters square. This is called as a surface area of the heat exchanger. Surface area of the heat exchanger. And last case is mass fluid of the cold fluid. In order to find the mass fluid of cold fluid, Q is equal to heat given by the hot fluid is equal to MHH, that is THI minus TH naught is equal to MCC TC naught minus TCI. Heat given by the TC naught minus TCI. So here Q is equal to, we already calculated, that is 91.35 into 10 power 3. MC we need to find. MC is the specific heat of water will be standard value, that is 4186. This is 4186, and temperature of the cold fluid outlet will be 65, and cold water inlet temperature is 25. Substitute all these things. So from this we can find MC is equal to Q divided by Cp into T2 minus T1. So Cp cold fluid. So from this we can write, we can get mass fluid of cold fluid is equal to 0.545 kg per second. This is called as mass flow rate of water, that is cold fluid. So finally the results we obtained as Q is equal to 91.35 into 10 power 3, mass flow rate as 0.545 kg per second, and surface area will be A is equal to 1.455 meters square. Thus we calculated all the results. I hope you understand the problem solution. For more videos you can subscribe my channel by clicking subscribe button in the video at the corner. Thank you for watching. Thank you.